This is what the shortest of a scheduling algorithm. In the last class we have discussed the first come first serve manner, that is a non-preemptive scheduling algorithm. And here first which one is processed? So first shortest job, that means in the ready queue number of processes are stored, in that which process have minimum burst time, so that is first processor, that is associated with this shortest job scheduling algorithm, associated with each process the length of its next CPU burst time. Okay, every process associated with the length of next CPU burst time. So these lengths to schedule the process with shortest time. Okay, how this the which one is selected? So next which process have the shortest time, that is first selected. Here two versions are there. One is a non-preemptive version and other one is a preemptive version.
Madam, voice madam.
So one is the shortest version and other one is the non-preemptive version and preemptive versions. So coming to the non-preemptive version, so once the CPU gives to the process, it cannot be preempted until completes its CPU burst time. That means, so in the first come first serve manner, that is a non-preemptive version. Once the CPU given to one of the process, so that process never preempted from the CPU until and unless the CPU burst time is completed. That means how much time is required to execute that particular process. So that much of time is completed, then only that process comes out from the CPU. That means అంటే ఒక 10 మిల్లీ సెకండ్స్లో మనకి ప్రాసెస్ కంప్లీట్ అవుతుంది అంటే 10 మిల్లీ సెకండ్స్ కంప్లీట్ అయిన తర్వాతనే ఆ ప్రాసెస్ మనకి సిపియూ నుండి బయటికి వస్తుంది. సో దట్ ఈస్ వాట్ ద నాన్ ప్రియంటివ్ scheduling version. So coming to the preemptive scheduling version, so if a new process arises with a CPU burst length less than remaining time of current executing process, so now it is preempted. That means whenever one process is executed in the CPU, whenever one process is executed in the CPU, in that situation some other process enter into the ready queue, so that process burst time is minimum, whereas compared to the burst time of whatever the process currently executed in the CPU. అంటే సిపియూలో ఏదైతే ప్రాసెస్ ఎగ్జిక్యూట్ అవుతుందో ఆ ప్రాసెస్ కంటే తక్కువ బస్ట్ టైం ఉన్న ప్రాసెస్ కనుక రెడీ క్యూలోకి వచ్చింది అనుకోండి, నౌ వాట్ ఎవర్ ద ప్రాసెస్ అంటే సిపియూలో ఏ ప్రాసెస్ అయితే ఎగ్జిక్యూట్ అవుతుందో దట్ ప్రాసెస్ కమ్స్ అవుట్ ఫ్రమ్ ద సిపియూ అండ్ నౌ which process have minimum priority, so that process enter into the CPU for execution. That is in the preemptive version, that is if a new process arrives with the CPU burst length less than the remaining time of current executing process. So currently whatever the process is executed inside the CPU, that process burst time is maximum, which whatever now the new process arises with the CPU burst time is less. That means in the ready queue loki oka new process add avutundi. So while adding that new process, so that ready queue burst time, that means that whatever the new process arrives into the ready queue, that process CPU burst time is less than or minimum to whatever the process is executed inside the CPU. That means remaining time of current execution. For example, suppose P1 is one process, so that burst time is 10 milliseconds. After completion of 5 milliseconds, so one process arrives into the ready queue, so that ready queue burst time is only 4 milliseconds. So here how much of time is left over out of 10 milliseconds? After completion of 5 milliseconds, new process arrives into the ready queue with CPU burst time is 4 milliseconds. And currently running process remaining time is what? 5 milliseconds. So that newly arrived process time is only 4 milliseconds. That means newly arrived process time is only 4 milliseconds. Okay, now see here, newly arrived process time is only 4 milliseconds. That means this is for P2. So currently in the process in the CPU, P1 process is executed with burst time is 10 milliseconds. After completion of 5 milliseconds, so this P2 process came into the CPU. P2 process in this P2 process with burst time. P2 process with burst time. So see, that means after completion of 5 milliseconds, P2 process enter into CPU. That is with burst time is 4 milliseconds. So 4 milliseconds burst time to enter avutundi. So now compare this 4 milliseconds. So now compare this 4 milliseconds with this 5 milliseconds. Automatically this 4 milliseconds is less than this 5 milliseconds. That is what here. If a new process arises with the CPU burst length less than remaining time of current executing process, in that situation, so this P1 is preempted from the CPU and now P2 is assigned to the CPU for execution. So this type of version, that means shortest job with preemptive version is called as shortest remaining time first. Shortest remaining time first. That means non-preemptive version is nothing but shortest one is first selected, and until whatever the burst time is given to that process, once the burst time is completed, then the process complete come from the CPU. That means emptied from the CPU. Whereas in preemptive version, so if new arrival process burst time is less than the remaining current executing process, then this currently executing process, that means P1 is preempted from the CPU and P2 is assigned into this CPU. Now this type of version is called as shortest remaining time first, and non-preemptive version simply say that shortest job first. Coming to the preemptive version, another name for the shortest job with the preemptive version is called as shortest remaining time first. So here shortest job first is optimal, gives the minimum average waiting time for a given set of processes, comparatively first come first serve manner. Okay. Next, so this is the example for non-preemptive shortest job first. So these all are the burst times, these all are the arrival timings. So these four are the processes. Now see the Gantt chart here. On this Gantt chart, so this is the time unit. Okay, for every at 0th arrival time, which process is enter into the CPU? That means this process. So here you can observe one thing. Suppose if there is no arrival timings are given, in that case which process is first enter into the CPU? P3 process is first enter into the CPU, and after that P2 and P4 both have the burst time same, that means 4 milliseconds. So in that case first P2 is selected and after that P4. That means this lower ID process is first enter into the CPU for execution, and after that another process P4 is executed into the CPU. So this is what that means confusion can solve by using this case. If both the processes have same arrival timings, in that case which one is first enter into the CPU for execution or for processing? So which process has the lowest ID? So that process is first enter into the CPU for execution or processing. So if in the question arrival timings are given, so first which one is processed? That means shortest job first one is first completed, but in this case shortest job is entered at 4 milliseconds. After CPU starts, after completion of 4 milliseconds only this P3 process enter into the CPU. But arrival time 0, P1 process enter into the CPU. Once this process enter into the CPU, so this is what the non-preemptive version. So that until and unless this burst time is completed, then the process is comes from the CPU. That means once this process P1 assigned into the CPU, after completion of 7 milliseconds only this P1 process come from the CPU. But here that means here 0, 1, 2, 3, 4, 5, 6, 7. After completion of 7 milliseconds P1 process completed. Then next you can observe here 2, 4, 5. So at that means 2 at second millisecond, 2 milliseconds, another process, that means P2 process enter into the ready queue. At 4th millisecond, P3 process enter into the ready queue. At P4 process at 5th that means 5 milliseconds, P4 process enter into the CPU, enter into the ready queue. That means at 2 milliseconds P2, at 4 milliseconds P3, at 5 milliseconds P4. Suppose after here how bus time is what? 7. That means after completion of P1, all these remaining 3 processes are stored in the ready queue. That means P2, P3, P4. All these 3 processes are stored in the ready queue. So now out of these 3 ready queues, out of these 3 processes in ready queue, which one is first selected? Now which one had the shortest burst time? So that first selected. That means P3 process is first selected. So now after completion of this one only, the next P2 and P4 both have the same burst time, so that P2 first processed, after that P4 is first processed. That means here you can observe 0 to 7. That means completion time for P1 is what? 7. Completion time for P3 is 8. Completion time for P2 is 12. Completion time for P4 is 16. Now find the waiting times. That means waiting time for P1 is 0. Waiting time for P3 is 7. Waiting time for, that means not 7. So coming to the P2, waiting time is what? Here P2 enter into the CPU at 8 milliseconds. Okay, and when the CPU, that means when this process enter into the ready queue, that means 2 milliseconds. That means 8 minus 2 means 6. Okay, waiting time means when that process enter into the CPU minus arrival time. Okay, 8 minus 6. So coming to here P3. So P3 entered 7 milliseconds. The burst time, that means arrival time is 4 milliseconds. That means 7 minus 4. 7 minus 4. That means this P2, P3 process is in waiting position. That means ఎంతసేపు వెయిట్ చేస్తుంది ఇక్కడ మనకి? So at what time? That means 1, 2, 3. This 4th millisecond the CPU P3 process enter into the ready queue. That means after entering into the ready queue, so at 7th millisecond P3 is executed in the CPU. That means how much time? That is in waiting position. That means 1, 2, 3. 3 milliseconds the process is in waiting position. That means waiting time for this P3 process is 7 minus 4 means 3. Whereas coming to the P4 process, the P4 process is enter into the CPU at 12th milliseconds. Arrival time is 5. That means 12 minus 5 means 7 milliseconds are waiting time. That means total average time for this is what? 6 plus 16 divided by 4 equal to 4. Average time for this one is 4. Average time for this one is 4. At the same algorithm we are see the non-preemptive version. Suppose here non-preemptive version means, so based on these arrival timings the process is come out from the CPU. That means so initially at 0th milliseconds, that means here P1 process is enter into the CPU because the arrival time is 0 milliseconds for P1. So after completion of 2 milliseconds, that means initially P1 contains 7 milliseconds burst time. So after completion of 2 milliseconds, now P2 enter into the CPU. That means its burst time is 4 milliseconds. Here the minimum remaining burst time is what? 5 milliseconds. Here 2 milliseconds are completed. Okay, here 4 milliseconds. So that this is the minimum one. Now it is preempted and the P2 is enter into the CPU. So after completion of 2 milliseconds, now burst time is here what? 2 milliseconds. P3 process enter into the CPU. Now the P3 process burst time is 1. After completion of 2 milliseconds for P3, how much remaining here? 2 milliseconds. That means now 1 is for P3 process, for P2 process 2 milliseconds. So that automatically here P3 process is entered into the CPU. After completion of 1 milliseconds, next that means at 5th milliseconds P4 process is stored into the ready queue and enter into the CPU. Okay, so before that, first of all, this is enter in, and the P4 process enter into the CPU. Okay, all four, that means P1, P2, P4, all three processes are in the CPU, but out of these three processes, here the 5 milliseconds, here 2 milliseconds, here 4 milliseconds are there. So from among these three processes, which one has minimum shortest or minimum burst time, that is for P2. So that P2 is executed 2 milliseconds. After completion of these 2 milliseconds, now P2 is completed, P3 is completed. Now coming to the P1 and P4, which one has minimum, that is P4 has the minimum. Now 11 milliseconds. Now after completion of this one, next P1 is assigned into CPU and complete its execution, that is 11 plus 5, 16. That means this is what the, how we are finding here average waiting time. Now see here, this is a 0, that means at 0th time this process is enter into here, but coming to here 11 milliseconds again the P1 process is entered, that means 11 minus 2, 11 minus 2. So how much time the process is here in the CPU? 2 milliseconds. That means next time the process is entering the CPU at what time? 11 milliseconds. 11 minus 2 nothing but 9. Plus coming to the P2 process. So P2 process is entered into CPU at 2 milliseconds, and after here, that means at 2 milliseconds, that is what is the arrival time? 2 milliseconds only. Okay, so there is no waiting time for this. Now coming to here P2, again after completion of this one, P2 is in the CPU up to 4 milliseconds. That means next at what time P2 enter into the CPU? 5 milliseconds. That means 5 minus 4 means 1. Okay, next coming to here 0 means here P3 process. So P3 process enter into the CPU at what time? 4 milliseconds. That means 4 minus 4, 0. Again the CPU burst time is only 1 millisecond, so that this P3 never enter again into the CPU, so that there is no waiting time for this P3. So coming to the P4, waiting time is what? 7. So now this is the 7, P4 is 7, that means arrival time is what? 5, that means 7 minus 5 is nonsense 2. This is what average waiting time for this. So here 3, so in the preemptive version average waiting time is 3 milliseconds. So coming to the non-preemptive version, average waiting time is 4. Okay, now here so in this case you have some ambiguity to find out these average waiting times. So that first of all you can take this 11 minus 2. So this is some ambiguity, so that you can see another example for this one. See here. Now observe here, this is the shortest job first. Here this is the shortest job first algorithm. This algorithm works on the given bus time. So out of these processes, which process have the minimum bus time, that is first enter into the CPU. Okay, now first draw the Gantt chart for this. Here this is P1, so arrival timings are given here. At P1 this process is first process, that is this is a non-preemptive version. The mode of this shortest job first is non-preemptive version. So that first these 6 milliseconds, after completion of these 6 milliseconds only, next can observe here 0 to 6. That means once now observe here the arrival time 0, 1, 2, 3, 4. That means all the processes are stored in the ready queue. That means P2 process, P3 process, P4 and P5. That means all 4 processes have bus timings, arrival timings are 1, 2, 3, 4. So here completion of P1, after completion of P1 process, that means 6 milliseconds are completed. Means all the remaining processes are stored in the ready queue. So now P2, P3, P4, P5, out of these 4 processes, which process is first selected by the short term scheduler? That means which process has minimum bus time, that is P4 has a minimum bus time. Now this is first selected, that means 6 plus 1, 7. Okay, so a turnaround time for, that means completion time for this P4 process is 7. Now this P4 process is leaves from the CPU and another process is sent into the CPU for execution. That means here P1, P4 both are completed. Next P2, P3, P5. From these P2, P3, P5, next select which one is the shortest one. That is P3 process is the shortest one. Now this is selected and next 7 plus 2, that is 9. Completion time for this P3 9 milliseconds. Then next from P2, P5, so which one is selected first? That is P2 is first, because this P2 bus time is 3, P4 bus time is 4. So that out of these 2, which one is minimum? P2 is the minimum. So first P2 enter into the CPU, then next P5. So this is a gunshot. Then next find out the turnaround timings and waiting times. Okay. Before that you can take the completion timings. That means for P1 6, for P2 process 12 milliseconds. So coming to the P3 9 milliseconds, coming to the P4 7 milliseconds and coming to the P5 16 milliseconds. So next find out the turnaround timings. That means turnaround timing formula is what? That is completion time minus arrival time. That means 6 minus 0 means at what how much time is required. That means here coming to here completion time for this P2 12 milliseconds and average waiting time is P2. That means how much time the process is in the ready queue plus how much time the process executed in the CPU. So that is called as a turnaround time. How we can get the turnaround time? That is completion time minus arrival time. That means 6 minus 0, 6 milliseconds, and after that second process, that is completion time is 12 and arrival time is 1. That means total time is 11 milliseconds. That means 11 milliseconds the process is in the ready queue as well as in the CPU. Okay, now 9 minus 2, that is 7. Now coming to P4, 7 minus 3, 4. Coming to this completion time, that is 16 minus 4, that is 12 milliseconds for P5. And coming to the waiting times, that is formula for this turnaround time minus burst time. That means turnaround time in the sense ready, that means how much of time the process is in the ready queue plus the process is in the CPU. That is called as a turnaround time. And coming to the waiting time means process is how much time the process is in the ready queue. That means for enter into the CPU. That means waiting time. That means 6 minus 6. That means total turnaround time is 6 and burst time is also 6. That means 6 minus 6, 0. Waiting time for the P1 is 0. And coming to here, waiting time for this P2, turnaround time minus burst time 3. That is 11 minus 3, 8. So suppose you can observe here P2. So P2 first enter into the CPU at what time? 9 milliseconds. So now observe here what is the average arrival time here? 9 minus 1 means 8. So in this way also we can find out the waiting times. That means first response means when the process enter into the CPU and minus arrival time. So that is also given, that is also gives the waiting times. But this is very easy whenever we can find the shortest job with non-preemptive version. So this is the ambiguity while finding the waiting times in shortest remaining time first. So that directly you can use the formulas, that is turnaround time equal to completion time minus arrival time, waiting time equal to turnaround time minus burst time. So this is very easy to find the waiting timings as well as turnaround timings. Now coming to the P3, that is turnaround time for this P3 process is 7 and waiting bus time is 2. That means waiting time is what? 5. Suppose you can come to here. P3 process enter into the CPU at 7th millisecond. Now arrival time is 2. So that waiting time is 5. So this is also another way to find the waiting times. Next coming to P4, that is turnaround time is 4 and bus time is 1. So that this is 4 minus 1 3. Now 12 minus 4 8. So total turnaround timing is 40 milliseconds. Total waiting time is 24 milliseconds. Now coming to this is average waiting time is 8 milliseconds and average turnaround timing is 8 milliseconds and average waiting time is 4.8 milliseconds. Suppose using this same information, apply some shortest remaining first algorithm. In that case, average waiting time is automatically decreased. So because shortest remaining time means whenever the process enter into the CPU, while executing some process, another process enter into the ready queue with minimum bus time. In that case, whatever the process is executed in the CPU, that is comes from the CPU, and minimum bus time process is entered into the CPU, so that average waiting time is minimized. Okay. So in the next we can discuss that average waiting time, how to minimize the average waiting time with shortest of first with the mode preemptive version. So that is that algorithm is called as shortest remaining time first. Okay, thank you. Stream ఇంత స్లో అయిందో నా ల్యాప్టాప్ అసలు. ఆహా ల్యాప్టాపే స్లో ఉంది.